Hello, everyone, and thank you for coming. We are going to leave you with an impression of how important everything Jensen described this morning is for the enterprise, with a little bit of detail on how we're working together to build AI factories or agentic capabilities for enterprise customers. And this is something that is, I think, increasingly the focal point across IT. Last year, you would have heard a lot, it's the year of the agent. And this year, we're seeing those agents come to life, all of the exciting activity that you see in the OpenClaw project as a concrete example. And it's less about just the agents and more about bringing agents to production and bringing them into the enterprise. And so what we're going to talk about is how we can do that responsibly with performance. And the most interesting part is how critical the network is to putting this all together. And so if we want to categorize this year, we'll call this the year of production agentic AI. And interesting, we put this presentation together before the keynote, I promise.
It's true.
But you'll see some similarities. And so one of the things that I thought was interesting was if you think about AI in terms of the impact it's having across the industry, it's substantial, and you hear all the superlatives and all the different comparisons. And one of the comparisons I was thinking about was comparing the transition from paper-based work to digital work, and specifically with the mainframe. So it was kind of interesting to see Jensen kick off with a picture of a mainframe and a discussion of how data and the data center is transitioning into an AI factory. As we're all experiencing, this whole world is moving unbelievably fast. And in that pace of change, one of the challenges for any enterprise is how do you keep up? Innovation can happen very quickly, especially in a small context, a small company or a small community. Absorbing that change into the enterprise is challenging. And so how you create an environment that is effective for the enterprise to bring in all of this change is something that I think we'll really spend the rest of this time focusing on. You see some ideas here around thinking in terms of an entire full stack, and specifically in that full stack where security is important. So it's defense in depth, something that's always been important, and it just continues to be critical, especially as you ask agents to do things on your behalf. Privacy has always been important, and there's privacy regulations depending on where you are in the world. Again, this takes on a new meaning when you're giving access to agents, to data, or to systems that allow agents to take actions on your behalf. So maintaining that sense of privacy, which is inclusive of not just your data, but some of your workflows and processes. You can think in terms of skills files or even prompts that if exposed out to the world, it might show something that's internally considered important and confidential. Bringing this all to the enterprise, I think, is also about creating some kind of consistency or a platform view of the world. And Jensen spent quite a bit of time talking about the platform this morning, both from a hardware point of view and a software point of view. And I think that's enabling an enterprise to create a focal point, which is a focal point for operations teams for efficiency. And it's also a focal point for the developers who are building agents or leveraging a common set of infrastructure so that you're not having to relearn different tools in every different context, which again is something that's critical from an enterprise point of view. And all of this is in pursuit of building that AI factory. To think in terms of token production, we often talk about tokens per dollar per watt. So how much can you drive down the cost of token production and fit it within your power envelope, which is really important for any enterprise. Tokens become cost on one hand, and they become business value on the other hand. So we're translating this cost into business value. So we want to make it as inexpensive as possible to produce the most value that you can for your business. Bringing the agents and agentic AI into the enterprise is non-trivial. I talked a little bit about that security picture, a little bit about how do you build consistency. If everybody's bringing their own viewpoint into the enterprise, you create a whole new set of challenges. But operationalizing agents is sort of the next challenge. So we lay this foundation, we create consistent guardrails and security with defense in depth and a consistent platform. How do we build a set of capabilities for the enterprise that are easily accessible so that they're not having to think in terms of all of the disparate parts of their business, which is challenging. I work for Red Hat. We're an enterprise. We have a bunch of different internal systems that we're working on going through this sort of agentic transformation. Most enterprises have that same experience, but also the tools are quite complicated. You saw a lot this morning around the rack scale architecture, which is bringing a collection of co-engineered hardware and an ecosystem of software partners in a sort of reference architecture type of point of view to reduce the complexity for the enterprise to go build this for themselves. If everybody's assembling something from scratch, it's really challenging. And that's where you get stuck in the pilots and the prototypes and the POCs that never really make it into production. So our goal here is to build a platform and maintain that security, create the consistency, and make it easy for enterprises to turn their business challenges and their data into a set of opportunities through the introduction of an AI factory. This is something that for Red Hat isn't exactly new. We've had this experience before of fragmented, fast-moving technologies. We've worked across the collection from the early days of Linux, fragmented Unix, and transitioning into a consolidated, consistent platform, bringing an ecosystem around that. We have built low latency, high throughput computers for the financial services market. We have brought this into the telecommunications industry, building 4G and now 5G networks. And again, in those contexts, it's a similar story of reducing complexity so that those businesses can quickly get to the value for their business. And here we're just talking about that, but it's times 10, or maybe it was times 40 million. I'm not sure.
Big numbers.
Big numbers regardless. And it's because the AI stack is substantially more complicated. It's deeper. If you've played around with any of the tools that pull in a large number of Python dependencies, you get a feel really quickly for how much this can explode and then become a challenge to maintain and lifecycle manage as you go forward, which is really a critical part of putting anything into production in the enterprise. So that's the context. And this is what really brought work from NVIDIA and work from Red Hat together, where our focus was on leveraging our shared skills, where we are really highly capable in our respective areas, amazing hardware, amazing AI capabilities that sit well above the hardware stack, working together with Red Hat, bringing in the low-level enablement of the hardware and software, so an operating system, distributing that capability across a cluster with something like Kubernetes, and then bringing in reference architectures, blueprints, enabling easy deployment of something like a NIM or an inference microservice in a container on Kubernetes, so that feels like a very standard process for IT, just like deploying an application would be. And so this is how we're helping developers bring agents to this common platform and helping businesses transform themselves with AI factories and introducing this sort of at-scale view of AI. So it's not just here in each different pocket of the organization doing your favorite task that you've offloaded to an agent, but it's collective end-to-end workflows that are leveraging internal data deployed and lifecycle managed in ways that are familiar to the enterprise and taking advantage of the remarkable scale and capabilities that come from hardware and then go up through all of the wild things that you see in today's models and agentic frameworks and the CUDA X libraries that Jensen mentioned this morning. So I think with that, I will hand it over to you so you can talk about the cool stuff at the bottom of the stack.
The foundation, the bottom layer of the 5-layer cake that Jensen was talking about today. So yes, Jensen did a great job for us, actually. He was talking about vertical integration and horizontally open, and he was talking about the 5-layer cake, and I think we're going to go over all of these concepts. So, 5-layer AI is a 5-layer cake. At the base, you have electricity powering these processors that deliver compute power. On top of this, the infrastructure, and then the models and the money-making applications on top of it. So we're going to spend some time at the base of the cake on the infrastructure part. And you saw it today on stage. Jensen presented the Vera Rubin platform. It's our first fully accelerated compute platform. And it's presented as based on these 6 processors, but it's a little bit misleading, and I think, Jensen explained it earlier, it's not 6 products glued together. It's 6 products that are deeply, developed, integrated, extreme integration between this product at the protocol level, at the silicon level, of course, and all of this in order to make a consistent data center that is optimized for all of its tasks. So you can see here the Rubin GPU and Vera, and we now all understand that Vera is not just yet another CPU. It has a lot of things to do, and it's important for the rest of our discussions, right? The CPU sitting on the node has many roles besides just hosting this compute node. And then we have all of the networking processors here, and we have the scale-up NVLink switch, and the scale-out Spectrum-X and ConnectX and Bluefield, and we'll talk about this in a minute. Basically, all of this now built into a coherent system, and the purpose now is how do we bring this to enterprise in a way that is consumable for our customers. Now, obviously, software is the answer, right? And NVIDIA, for this purpose, developed what we call NVIDIA AI Enterprise. It's basically the software stack that makes this infrastructure foundation usable for enterprise. You mentioned it, right? It's very complex. If you have to deploy such a system, you're faced with tons of complexity, different compatibility issues, security churns, and whatnot. And NVIDIA understood this, and Red Hat as well, of course. And so we basically created this fully validated stack, production-grade software stack, in order to help our customers, enterprise IT, to leverage our hardware. You can think of it as the operating system of the data center. So it has many layers. I started with the bottom part of the cake. I will go from the top to the bottom. We have all of these business applications, pre-trained models, CUDA-X library, you mentioned it as well, infrastructure management, you were talking about lifecycle management, multi-tenant operation, and so forth. You need to deal with all of these things. And the beauty with the NVIDIA AI Enterprise framework, because it's a framework, and Chris, you'll show us in a minute how you leverage that, right, is that it's, you develop once, and then you can deploy anywhere. Right? You can deploy in your workstation, in your cloud, on-prem, et cetera, et cetera. So that was the idea. How do we make all this infrastructure available in an easier way? But of course, we need partners. We need this horizontal openness that we were talking about. Chris, do you want to explain a little bit more how you leverage NVIDIA AI Enterprise?
Sure. Well, actually, I think that notion of develop and then deploy with flexibility is really an important thing to highlight. We hear about that a lot in the application context with something like hybrid cloud, deploying within your data center or deploying in the cloud. And that has not changed. In fact, in some cases, it's gotten more important in the context of AI, especially where there's data residency and data sovereignty concerns, and where you build and deploy your agents can become really important, inclusive of your security story and your internal compliance. The picture, if you zoom out a little bit, of the Red Hat AI Factory with NVIDIA, there's that NVAIE component, which is a key part of this overall stack. And you could think of it as, for a moment, we'll only talk about 3 conceptual layers. The foundational hardware layer, which is coming from NVIDIA, building the rack scale architecture with Vera Rubin, or even with something like the Grace Blackwell GB300. Then there's the enablement platform tier, which sits above that. That's the operating system, that's the distributed system of Kubernetes. And then as part of that, there's a set of additional capabilities that come from layering NVAIE on top of this platform. And now we have, from the bottom up, a high performance, scaled out inference platform with a set of models that are tuned to run on this platform. And those models can then be delivered with an API wrapper around them. So that's something like the NIMs that give compatible standard ways of accessing the model. And those models become the foundational building block for the applications that sit on top. And so this is the Red Hat AIE and NVIDIA NVAIE really interleaved and combined together into one integrated stack, bringing the best of breed of all of what each of us are providing, maintaining that sense of flexibility and choice. There's many models. You can always start from the very bottom of the stack. If you're a developer wanting to build an agent from scratch, you could use a framework if you want to leverage a framework. And all of that can be deployed on this common platform, again, sort of picking the right tools, and then we deliver that reference architecture to make it easy to consume within the enterprise. So it's one standard platform, there's pre-integration, and then something that we talked about together, NVIDIA and Red Hat, earlier in the year was Red Hat supporting the hardware from day 0. And again, really important for the enterprise. In fact, this started with a kind of an interesting conversation with Jensen, who was saying, well, hardware, 1 year major architectural shifts in hardware, in some cases can be outpacing the life cycle of software, these core software platforms. So, hey, Red Hat, can you work with us to make sure you're available and prepared on the same cadence as the hardware? So this day 0 support for us, I think, is really, really important. There's still an aspect of development that happens in respective upstream communities. We work together in communities like the Linux kernel community, the Kubernetes community, the VLLM community, and in those contexts, our shared goal is to make sure those changes are merged into the respective upstream communities. That can be a process that takes some time, and so part of providing day 0 support is ensuring that we have a production way to bring this into the enterprise and a long-term way to lifecycle manage these changes, inclusive of that upstreaming process. So we're not short-circuiting that, we're just ensuring that we have day 0 support and then a longer lifecycle so that we can cadence with the enterprise, which is interested in the day 0 support, and as things stabilize, they're gonna wanna put that one in a fire and forget mode and just let it run out its enterprise lifecycle as there's new capabilities coming into newer hardware and newer software. So it's a really challenging landscape when it comes to enterprise and absorbing all this innovation that I mentioned earlier, and this is a concrete example of how we're helping manage that. Yeah, I think that's it, and now we can talk about networking, which is
talk about the good stuff.
something that is really what brought us together to produce this talk.
Yes. So, networking is at the core of this cooperation, and at least a significant part of this cooperation, and we'll try and explain that in a minute, but maybe kind of giving first a high-level picture of why it is important, why do we care at all, right? Years ago, you just needed to connect your compute node with whatever in order to make them talk. We understand that now networking is really what defines the data center. Jensen showed all of the latest technologies of networking, the NVLink scale-up, the ultra-fast GPU interconnect technology that make these racks of 72 GPU talk to each other and appear like one big logical entity. But the most important part, which I guess we'll discuss today, are two other parts of the networking infrastructure. One is the scale out, right, with Spectrum-X and Connect-X, talking about tight integration. I'll explain about this in a few more minutes. And then, so scale-out technology that enables connecting all of these racks together in a way that is efficient and with consistent performance. And the other part, which we'll discuss today, is the Bluefield Data Processing Unit, which basically runs the infrastructure of the data center. It's the infrastructure processor of the data center, and there is a specifically very interesting collaboration on that because it brings a lot of value in terms of security. We're talking about security, but not only, and we'll explain why in a minute. By the way, I just listened to as many of us today, and I was thinking that I missed a slide about why Enterprise AI Factories did this today. Storage for AI cannot be an afterthought, cannot be, built on top. It needs to be designed with AI in mind, and there's a couple of Bluefield accelerated platforms that have been announced by Jensen today that are interesting, but maybe not for today's talk. Just wanted to mention it. So, moving to the Bluefield DPU, the reason why we came up with the idea of this Bluefield DPU is because we identified that there are three infrastructure needs and challenges for operationalizing AI, and they fall in like three main buckets. The first one is you need your infrastructure to have accelerated performance. We can no longer rely on moving data thanks to software-defined networking running on some CPU. It just doesn't scale, and it's just not possible for AI cloud and AI networking. The second thing is, and I think it's probably one of the most important, is we need infrastructure efficiency. Again, when you use your Vera cores to move data, you do not use your Vera cores to do AI workloads, which is really what, you don't want to, you're losing precious compute power and power in general, and you don't want to do that. So having an infrastructure that is highly efficient is also critical. And then advanced cybersecurity, with this new class of data-driven applications, there's quite a few security challenges. And in modern AI clouds, you really need the security to be built at each and every layer of the data center and to be deployable in a way that is close to where the data resides. And so zero trust in mind, this is also what motivated for us the need for a Bluefield DPU. So what is it? That's the beast. I think it's Bluefield 3. Now we're in Vera Rubin. We'll be deploying Bluefield 4. So it's basically an infrastructure processor. We used to talk about CPU and GPU, and then the DPU, the data processing unit, as the third part of this triad. It's a system that includes high-performance networking with a set of ARM cores, memory subsystem, and it's basically a programmable infrastructure processor on which you can run your security, your storage, your networking tasks. So we used to say that it offloads, accelerates, and isolates infrastructure. So offloads, just simply because rather than using your CPU cores that sit on the host, you can take all of these infrastructure tasks and run them on the Bluefield, and then you free your CPU for money-making applications. Accelerate, because there are a lot of built-in acceleration that enable you, for instance, to do crypto at line speed or storage acceleration, many more things. And it basically enables you to deploy your infrastructure at scale. And then isolate, because if you think of it, it's a little bit like a computer, right? Some I/O, some memory, some compute. A small computer in front of the computer. And in this small computer, you can actually run all of your security, networking rules, in a way that is isolated from the host. So think of a multi-tenant environment. Your host is, has been attacked, right? All of your networking, all of your security is now encapsulated in this separate area, all right? And cannot be reached. It's isolated from a security perspective. So that's Bluefield. Bluefield today expanded to do some storage processing, so it's much more than just that. As in every piece of hardware, you need your piece of software that goes with it, right?
Yeah, that's right.
And so Doka is our framework. It's basically a set of SDKs, libraries, pre-built services that run on top of Bluefield and make it a software-defined, hardware-accelerated platform. I just want to say that we have a Doka Developer Day tomorrow afternoon, so that's the piece of information that it's going to be a lot of interesting sessions about security and storage and more on Doka. So that's Bluefield, and the beauty of it is that Bluefield today is part of all of NVIDIA platforms. So if you look at enterprise, RTX Pro servers, all of the NVIDIA certified systems delivered by our OEMs have Bluefield in it. Same for, of course, NVIDIA AI factories. Bluefield is the infrastructure processor that is integrated into each and every one of these platforms. Why this long introduction in Bluefield? Well, because that's one of the really interesting places where Red Hat and NVIDIA, we cooperated to bring an accelerated infrastructure solution for our enterprise AI cloud. We've started cooperating on that about a couple of years ago, I think, right?
Yeah, it's been quite a while.
It's been quite a while.
It started even in the SmartNIC days and into the DPU. So
long time ago.
Together. Yeah.
But last year, Red Hat announced official support of Red Hat OpenShift on top of Bluefield, right? Yep. So that was a big milestone, and we're just continuing from there. What Red Hat OpenShift on NVIDIA Bluefield delivers is all of what we discussed before. Enhanced cloud networking, advanced cluster management, secure application platform, a secure enclave, right? The small computer in front of the computer running OpenShift now. And of course, cloud native development platform. And you can see here there's a kind of an illustration of what a data center would look like without Bluefield and what it looks like now with Bluefield. So on the left-hand side, we're looking at traditional servers running OVN Kubernetes networking on top of RHEL CoreOS. On the CPU, you can see you have a number of virtual machines and containers, a smaller number of virtual machine and containers because, hey, part of the cores are busy, moving data and doing stuff. On the right-hand side, you have now your Bluefield accelerated server. And it's running, and we have NVIDIA Bluefield DPU, which itself is running Red Hat CoreOS, leveraging NVIDIA Doka, and has an OVN Kubernetes networking on top of it. So it's really delivering the best of both worlds for enterprise IT, because it's the good OpenShift experience, I guess, for your customers, and you'll tell more about that.
Yeah.
But with a platform that is accelerated, isolated, offloaded.
Yeah.
That's, I think, part of the beauty of our cooperation.
It's a neat story because, as Yael mentioned at the beginning of that description of the Bluefield DPU, performance is critical. And at high speeds, the inner packet spacing is actually so small, measured in nanoseconds, that it starts to match clock speeds of CPUs. So the number of CPU cycles you have to even touch a packet is quite limited. And when you have all these packets flowing through your system, all your CPU is doing is looking at a tag, doing a lookup, pushing a packet somewhere else. And while that's an important job, it's actually not the job of the server CPU, which is there to support application workloads. So getting that infrastructure capability off of the primary CPU, making space for application workloads to benefit the business, is one of the cool things that's really interesting. And then the flexibility of the Bluefield architecture, which includes a general purpose ARM CPU in it, as well as these specific offloads or accelerators that are part of the NIC, gives you a lot of flexibility in what can be deployed there. So the fact that we have a normal Linux and a port of the OVN Kubernetes networking capabilities to Docker-enabled capabilities within the DPU is a great illustration of what that looks like. If you look one step further, OpenShift has this notion of hosted control planes. And so Kubernetes works in clusters. A cluster has a collection of worker nodes and then a collection of control plane nodes. And those control plane nodes are giving instructions and scheduling tasks to the worker nodes. The control plane nodes can be loaded onto a shared set of compute, and then you could host a set of control planes, one per cluster, and you get better efficiency that way. So you just don't have as much overhead per cluster with these control plane nodes. What's really interesting is you can take that concept and actually bring the control plane nodes all the way down into the DPU. And so in the earlier days, we would call it a server within a server, but this kind of capability that is pretty general purpose on one hand, but then also has these fixed function capabilities or accelerators, makes it highly flexible. It's out of band from the primary host CPU point of view, which is part of that isolation story, so that now you have all of your infrastructure out of band from the application space. So you can really separate the two worlds, which actually improves your overall security story. So it's an improvement on the performance because you're taking the packet processing and putting it right back into the NIC where it's designed. There's ASICs designed specifically to do this. You're carving out the infrastructure into a set of infrastructure processing units that are creating space for the applications. And then you're building better isolation between those two worlds. So it's a pretty awesome collection of software and hardware. And I can tell you as a former kernel developer, one of the coolest things you can do is log into a network interface card and get a bash shell and realize it's running Linux. It's just it's a really cool experience. And from an enterprise point of view, that separation, that isolation, managing the performance, and then creating more space on the host to run typical applications, as well as what we're talking about here, which is ultimately AI-based agents. That's the primary purpose of the hardware. Everything else is in support of that. So to me, I think this is a really cool story. And then if you bring that, zoom out a little further, it is leveraging the work that we've already done together in the OpenShift platform space. I mentioned earlier this notion of using this in the financial services industry, using this in the telecommunications industry. There's some examples here where you can see a lot of work with networking, especially focused in telecommunications. In some cases, this just are a set of applications that run on top of the platform and take advantage of this isolation and acceleration and offloads. In some cases, we're actually working with these same companies and bringing that right directly into the NIC. So we're doing, or into the DPU. So we're doing this acceleration and offloading in a way that's improving the performance of the overall system and improving isolation. So it's a really cool, to me, it's more than just the technology, it's the ecosystem that's around it that we're building together.
It's the horizontal openness, which we were vertical integrated and horizontally openness that we were talking about earlier on today, I guess.
So we better get to SpectrumX before we start running out of time.
Yes, so SpectrumX is yet another angle of our cooperation, but just before, Chris, you explained how you integrated this in the Red Hat overall system, and a quick explanation of what SpectrumX is. SpectrumX is our scale-out technology. It's based in our Spectrum switches and ConnectX Ethernet NICs. And the idea of SpectrumX came from the same statement that if you look at traditional Ethernet, it's not very efficient for AI workloads. Collisions and congestion and long-tail latency and stuff like that. And so GPUs are sitting idle waiting for the data to arrive. And so that's where we started doing again, extreme co-design, we're talking about it. So extreme co-design here between the switch and the network adapter to deliver an AI scale-out fabric that is really tailored for AI. Nearly perfect effective bandwidth at scale. We're talking here for Spectrum-X, we're talking about 95% of bandwidth efficiency versus traditional Ethernet that would deliver about 60%, extremely low latency, a lot of algorithm and protocol level work to define advanced congestion control algorithm, adaptive routing, et cetera, et cetera. And at the bottom line is what we get with Spectrum-X is a very deterministic performance, not jittery, which is critical when you talk about GPU and AI workloads. And then also, if you have multiple tenants working on multiple jobs at the same time, there's no real interference in the network level. So there's kind of a fairness that Spectrum-X delivers. So that's the Spectrum-X system. How do you use it? How do you integrate it?
Surprising no one, we take advantage of integrating all of the capabilities that are critical to Spectrum-X into this rack scale design. So again, Kubernetes is operating at cluster scale, so it's at that rack scale. And we're bringing this enablement through the provisioning. There's the switch, but also the ConnectX NIC that's connected to the switch. And in the end, remember that what we're building is an AI factory. And that AI factory has high performance token throughput as its primary focal point. And in order to do that, we have a bunch of different networks. There's the kind of management network that we use to manage the system. There's the application network that's used to transmit application traffic. And then there's the critical high performance network that is connecting all of the GPUs. So you think what you would have heard before are things like RDMA over pick a transport, whether it's InfiniBand or Ethernet or similar. And here we're building this very high performance transport so that we can do the critical work of building distributed KV cache. You heard some of the concepts this morning in terms of disaggregation and making sure the right request is landing on the right GPU essentially at the right time, interleaved, and managing, jitter in this context looks like stalling a GPU, which looks like stalling value that you're producing for your business. So you kind of get this overall picture. The network is really critical in connecting all these different compute devices. It's critical in the isolation and security story, and that difference between application, traditional north, south, east, west, to introduce a management plane and this critical GPU fabric interconnecting that token factory essentially, I think is what we're doing here. And yeah, I think we'll run out of time, so we'll end it right there.
Ooh.
Yeah.
Yes, time's up. Do you want to maybe 30 seconds for conclusion? Chris, do you want to just to wrap this up?
Some example use cases, just so you don't leave wondering if this is only technology. Bringing RAG capabilities, bringing video search and summarization, bringing enterprise deep research. You'll hear a lot about that in the context of long-running agents and the Nemo Cloud discussion that started this morning in the keynote, or something simpler like GPUs as a service or models as a service as these key entry points for enterprises to build their capabilities around. So those are the core primitives of the AI factory, and this is what we're making easy on this Red Hat AI factory with NVIDIA.
Thanks,
we'll end it there.
Chris. No, yeah. I'm excited to this continued cooperation, and maybe next year we'll have more new stuff to present to the crowd.
Thanks for sharing the time with me, and thanks for sharing the time with us. Yeah.
Thanks, Chris.